Today we're going to talk a little bit about isosceles triangles and special things that go on within isosceles triangles. The first two theorems are pretty much converses of each other, and the shortcut of it is this. Basically, is if I have two sides congruent, I'm going to have these two angles down here also congruent. The angles opposite those sides must be congruent also. Conversely, if I have two angles congruent, B and C here, then the sides opposite those angles must also be congruent. So, shortcut, congruent angles give me congruent sides, and congruent sides give me congruent angles in triangles. Pretty straightforward stuff. Not really complicated at all. So in triangle DEF, if DE is congruent to DF, name the two congruent angles. Well, obviously, it should be fairly obvious in the picture what the congruent angles are. Angle F is congruent to angle E. If you're looking for a good visual cue, again, it's the angles opposite those sides. Those are the congruent angles. Copy and complete the statement. If HG is congruent to HK, let's mark what that is. HG is congruent to HK. Then what two angles are congruent? Well, the angles opposite. So angle G would be congruent to angle K, but I need to be specific here because there's more than one angle K. So I have to be very specific and say GKH or HKG. So I'll go GKH. Next question says if angle KHJ, so KHJ is congruent to KJH, then what must be congruent? Well, we have congruent angles, so the sides opposite must be congruent. So that's segment HK. Segment symbol is congruent to KJ. Again, the biggest trick here is just taking the time to actually read what's going on, to mark up the picture, and to make sure I've got the right pieces, indeed, and not am working so fast as to look at the wrong thing. Corollary to the base angles theorem says this: if all three sides are congruent, then all three angles are the same. And if all three angles are the same, then all three sides are the same. We already talked about this in the first lesson, where we said that equilateral triangles are automatically equiangular and vice versa. That's essentially what's going on here. Congruent sides give us congruent angles when it comes to triangles. And if I have three congruent sides, I'm going to have three congruent angles. And by the way, if I have three congruent angles in a triangle, and each angle has to have what measurement individually? Well, the sum of three angles is 180. We have to divide that by three even parts at 60, 60, 60. Those are the angle measures in equilateral triangle. So find the measure of angle PQ and R. Clearly it is an equilateral triangle, therefore each angle must be, we just said it, 60, 60, and 60. Equilateral triangles always have all 60-degree angles. Find the length of ST for the triangle at the left. Again, this is as obvious as it seems. It's all three angles are the same, so all three sides must be the same. So that's going to be a 5. And that's really it for today. One of the shortest, easiest lessons we've had all year. It's common sense. All you really need to do is slow down and make sure that you're looking at what's on the picture and labeling things properly. See you in class.